Welcome to Math with Miss Garrity. Our last unit in algebra this year is going to be determining which type of function best models data. So we're going to be comparing linear, exponential, and quadratic functions. We might be given information in a table. We might be given just a description. And so we're going to look at what we've been given and use the information we know from our previous studies to determine if we should pick linear, exponential, or quadratic to model the data. Some ways we're going to determine which type of function to use is we're going to maybe be able to write an equation. We are maybe going to be given a graph and we're going to be able to analyze the graph or examine data that's in a table. Let's go back to these examples I showed at the beginning. The table shows the population of Atlanta from 1970 through 2014. The purpose of writing a function to model data would be to make predictions. According to the data, based on the data, is there a pattern that maybe would let us predict what is the population of Atlanta going to be in 2030? So what we're going to do is, given a table, we're going to maybe see first, is it linear? From 1970 to 1980, there's 10 years difference. 1980 to 1990, there's 10 years difference. And then to 2000 to 2010, that keeps going up by 10 years. I'm not going to talk about this data point right now. But what I'd like to do, linear seems to be easiest for me. Is there a constant rate of change, 497,000 to 425,000? That decrease of 72,000, is that the same to get to 394,000? It's not. And is it the same? Do you go down again by that 72,000 to get up to 416,000? No. So I can at least determine that this example can't be represented by linear. And then we're going to find out how to look to see if it's either quadratic or exponential. In this description, Jane has $700 and is going to spend $50 each month for gas for her boat. Well, $50 each month, spend $50 each month. That tells us that given a starting point of $700, if 1 month goes by, that $700 becomes $650. And then if another month goes by, it becomes $600. So this is a linear situation because there is a constant rate of change. If we look at this data on the table, I mean, even just visually looking at it, there seems to be a pattern visually. So what is the pattern linear? No, we are not adding the same thing each time to get the next TNT amount. The magnitude, notice that our x coordinate, our independent coordinate being the magnitude, goes up by 1 each time. So how do we get from 0.6 to 6? You could multiply by 10, which then to get from 6 to 60, you'd also multiply by 10. So this data has a constant ratio, not a constant difference, but a constant ratio. And that is the definition of exponential functions. So this earthquake Richter scale situation can be modeled by an exponential function. What if I would give you some equations Can you identify the type of function just from an equation? I'm guessing you can. All three of these have been given to you in standard form, except this last one. But anyway, this function has a degree of 2 and is written in standard form for a quadratic. This example has your variable as the exponent. This is an exponential function. And this last one is not written in standard form. It's written in slope-intercept form, which is linear. Can you identify the type of function from a graph? Well, maybe, if you're given enough of the graph, but maybe not. So again, I'm going to teach you some ways to identify what type of function there is. I guess for function A, there's a constant increase, constant difference to get from one point to the next. So we can determine from this information that function A is linear. B and C, we might need a little more information because those might be quadratic and they might be exponential. Because I created these, I know the answer. I know that I made function B as a quadratic and I made function C as an exponential. But again, we'll get some more information on how to determine that for sure, certain. If you're not given an equation and you're not given a graph, there is a way to determine from just the table, and that is to find the difference in the y values. And we've done this. We've done this with linear functions, change in y over change in x. But the next lesson I teach you after today is going to be going into a second difference, which will give us some more data to pinpoint exactly the type of function. So again, here we are at our last unit of algebra for the year, and we are going to be given some data in different forms, and we are going to determine the best that we can if that data is linear, exponential, or quadratic. And there you go.